Hello, everyone. We are going to talk about moments today. We have discussed about force. We know force is a push or pull. Now we are coming to moment. Moment is a word that we use in our everyday life. We use it often. We use it to indicate an interval in time. Wait a moment. That's an interval in time. But in our context, in the context of engineering, moment means something else. Moment effectively means creating a rotational force. Let me explain. Force is a push or pull. But just push or pull alone is not enough to do our daily work. Many times we got to rotate. Think about a steering wheel. Think about your car, right? Think about pulleys. They have rotational motion, and that's an important motion that we need in our everyday life. How do we create that? Well, it can be done through force by using push or a pull. Let me give you an example. I have a wrench here, and the wrench is used to tighten a bolt, or maybe you want to loosen a nut. That's why we use a wrench. And the wrench, when it is held like this, and if I want to do something with that, I'm going to apply a force here. And when I apply a force, I'm actually pushing it, as you can see. So this push creates a moment about an axis here. What does that mean? That means moment is a rotational force. Or if you want a more formal definition, I would say moment is the tendency of a force to rotate an object about an axis. All right? So moment is the tendency of a force to rotate an object about an axis. And this is what we use when we are trying to do moment. Now, let me give you an example, some simple example like a teeter-totter or a seesaw. What happens, you have a teeter-totter, a board, supported at a fulcrum, and two people sitting on each side are applying a pushing force, and the pushing force creates that rotational moment. So it is actually a tendency to rotate. So moment is a very important concept in engineering, all right? And what we are going to do now is to learn how to calculate moment of a force about an axis in 2 dimensions. Very simple, very intuitive. Basically, we are going to take that force, multiply by some distance, all right? And that distance is going to be a perpendicular distance, and I'm going to explain that using an example. All right, so let's take a look at calculating moment in 2D. All right, let's take a closer look at moment. We just talked about moment. Moment is a vector, so I'm going to write it like this. I also told you in 2 dimensions, moment is going to be equal to force times distance. Here's a simple example. Something like a teeter-totter. All right. Let's say some weight here, and I apply some force here. Let's say I apply a 20-pound force. All right. And this force is perpendicular to this plate. And let's assume this distance is 10 inches. All right. So by definition, moment is going to be equal to force times the perpendicular distance. So 10 inches times 20, it is going to be equal to 200 pound inches. Notice the unit now. The unit now is not just pounds, not just inches, it's pound inches, and make sure you follow the appropriate unit. So in US system, the unit for the moment is going to be pound inches. In SI system, your unit is going to be equal to Newton meters. All right? So you know how to calculate moment, but moment is also a vector, as I mentioned. See that? It's a vector. If it is a vector, that means it has certain direction. And in this case, the tendency of this force is to rotate this about this point, say A, all right? And the tendency to rotate is clockwise. So the correct answer would be, if I want to answer this question properly, mathematically correct, vector moment or moment vector equal to 200 pound-inches clockwise. All right? That's the correct answer. So I'm specifying the magnitude of the moment as well as the direction. The clockwise moment is considered negative by convention. All right? Counterclockwise moment is considered positive. There is nothing like right or wrong about positive or negative. It is a convention that we have been using not just here in the United States, all around the world. So from now onwards, if you get a negative answer, that moment is going to be assumed to be in clockwise direction, otherwise counterclockwise. All right? So when we talk about moment, you should know the units, you should know the direction, and you should be able to find the magnitude of it by figuring out the perpendicular distance and the force. That's how simple moment calculations are done. Now, I want to draw your attention to a couple of different scenarios. Let me show you here another scenario. Same situation. Here I have my fulcrum. Here is weight. And force, instead of being applied perpendicularly, let's say it's applied at an angle. And let's say this angle is 30 degrees. And the fulcrum point is point A, and this force is still 20 pounds. Same problem, but you realize you cannot take this distance, which is still 10 inches, all right? Now you realize you cannot take this 10 inches and multiply by 20 pounds because the force is still not perpendicular to the position or the distance vector, all right? So what we have to do in this particular case is to resolve the vector into two components. And if I resolve the vector into two components, you are going to get an x component and a y component, as you can see, all right? So in this case, the y component is here, right? And that component will be equal to, as you can see, this force. And here we have a right triangle. And therefore, this component is same as this component, and this should be equal to, based on your trig knowledge, you will realize it is going to be 20 sine 30. And this component is equal to 20 cosine 30. But realize this component, which is along this position, passes through the axis here, meaning there is no perpendicular distance. Remember, moment is equal to force times perpendicular distance. But there is no perpendicular distance in this particular case, and therefore this x component of this moment will give you zero moment. X component of this force will give you zero moment. So the moment in this particular case is going to be created by this perpendicular force, and that moment is equal to 20 sine 30, all right, times this distance 10. So the magnitude of this moment is going to be equal to sine 30 is equal to 1/2. So 20 times 1/2 is 10. 10 times 100 pound-inches. And again, this is rotating clockwise. So that's your final answer. Moment of this 20 pounds force about point A is equal to 100 pound-inch, and it is in the clockwise direction. So realize calculating moment in 2D is very simple. Figure out the distance, the perpendicular distance, and then you simply multiply. And also look at the direction, clockwise or counterclockwise. It's very easy to do. Now I would like to do another problem, a little bit more involved than this, using components as well as using perpendicular distance, so you reinforce the concepts. All right, so let's take a look at another problem now. Hello everyone, let's solve one more problem, two-dimensional moment problem. And this particular problem is taken from the popular Beer-Johnson text, as you can see. Let's see what happens here. Here is a lever making a 65-degree angle from the horizontal. There's a 20-pound force applied at an angle again from the horizontal, And this alpha happens to be 25 degrees, so make a note of that. This alpha is 25 degrees. And the question is, determine the moment of this force about this point B. All right? And basically it is saying by resolving the force into horizontal and vertical components. But I'm going to show you a couple of ways of doing it. Also realize when I say moment of this force about this point, really about an axis through B. All right? Moment is always about an axis. In this particular case, the axis is through point B and it is perpendicular to the plane of this paper. Typically, if this is your x-axis, if this is your y-axis, the moment is about z-axis. All right? Now, if you go back to the definition of moment, remember it is perpendicular force or force times perpendicular distance. So, one way to look at this problem is if I extend this force like this and I drop a perpendicular, this distance d is the perpendicular distance I should know. And if I can figure that out, I can multiply this with the force 20 pounds, I should be able to calculate the moment. So can I calculate the perpendicular distance? It turns out it's pretty easy. Why? Because you have a right triangle here. And we know this total angle is 65 degrees because it is an alternate angle, of which this is 25. So this angle must be 40 degrees. All right? If this angle is 40 degrees, this is 9 inches length. Realize this is 9 inches. From distance A to B is 9 inches. And if I want to calculate this d, using Pythagorean, I can say the distance d is equal to 9, this distance, times sine 40 degrees. All right? I'm not going to calculate that. I will let you to calculate that. But that's the distance, perpendicular distance. Once I calculate the perpendicular distance, moment of this force about point B is going to be equal to force, which is 20 pounds in this particular case, times the perpendicular distance. All right? And if you did that, you will get an answer of 115.7 pound inches. And as you can see, this force is going to rotate or tend to rotate this object with respect to B clockwise direction. So that's the answer. Moment of this force about this point B is 115.7 pound inches in clockwise direction. Now in this particular case, we solve this problem not by resolving the force components into x, y, but by finding the perpendicular distance. I am saying this because there are a number of ways you can solve the problem. So do what you feel comfortable with. All right? Now, if you got this one, I'm going to solve the same problem by resolving this force into two components. So let me take the next handout. Same problem. The only difference is I'm going to resolve this force into two components. How do I resolve into two components? Again, if I assume this is an axis, so you could say this is your x-axis, this is your y-axis. You could do that. All right? If I did that, I project this force, the x component of the force is going to be here. Let me show that using a different color. So here is the x component of this force. And if I drop a perpendicular, this is going to be the y component of this force. The y component of the force, again by using trigonometry, let's take a look at the angles here. This is 25 degrees, all right? This is 65 degrees. So this whole thing is 65 degrees. This is 25, so this is 40. We did that before. Now this is a perpendicular. Therefore, this makes a 90 degree, 40, 25, 65. That leaves this is 25 degree. 70, yes. And this is 25 degree. So here we have a triangle, right triangle. This is 50 degree. And therefore, this force, the force along y-axis, let's say this is your x-axis, this is your y-axis, force along this would be equal to 20 pounds times cosine 50 degree. Please make sure you understand that. It's a simple trigonometry. I have a force projected onto this axis, and this angle is 50 degree, and I found the magnitude of that force. Clearly, this force will be 20 times sine 50 degree. But if you recall, this force passes right through the point B, meaning there is no perpendicular distance, and therefore there will not be any moment due to this force. That means the only component of moment is due to that force, and therefore moment of this force, this 20-pound force, about point B would be equal to force, which in this case 20 cosine 50 degree, times the perpendicular distance, and the perpendicular distance is from here to here, which is AB, and you know that's equal to 9 inches. And if you did the math, you would find out this is still equal to 15.7 pound-inches. And as you can imagine, this force is trying to rotate this object about this point B along a clockwise direction. That's the answer. So what we have done is solve the same problem by finding the perpendicular distance in the first instance, by resolving the force in the second instance. One word of caution here, instead of resolving this force along this axis, some of you may decide, I am going to resolve like this. So this is your real force, and you are trying to resolve it along this as your x-axis, and this as your y-axis. You can do that, in which case you'll have two components of the force, and you have to sum them up and calculate. And I'm not doing that because this is an easier way to do that, but if you decide to do this way, be my guest, you should still get the same answer. I would highly recommend you to finish up this problem by doing this way, the third way, and make sure you understand how to calculate moments. All right? So that completes our discussion on moment. You should know now what a moment is, the units of moment, how do you determine the direction, and how to solve moment problem in 2 dimensions.